one, Michaela, is this one left-tailed or right-tailed or two tails?
Left tail.
Okay, so let me draw the picture. Here's my fish. So which is bigger, the mu or the 43? The mu is bigger. So is it going to be left-tailed, right-tailed, or two-tailed? Right-tailed, because it's bigger. Does that make sense? Destiny, next one. Left-tailed, because my bean is smaller. I'm not called on. Daphne, I'm calling you. What's the next one? Two-tailed. And the last one, Diego, I'm calling you. Which one is that one?
Left-tailed.
Left-tailed, because it's smaller. Good. Great. All right, the rare event rule. Ryan, go ahead and read for me.
If under a given assumption the probability of a particular observed event is exceptionally small, we conclude that the assumption is probably not correct. In other words, if it is unlikely/unusual, then our assumption H0 is wrong.
H0 is wrong, right. So that's the whole concept. So in other words, we got 6 black cards in a row. If we're assuming that it should be half black cards in the deck, then it's really unusual to get, half red cards in the deck. It's really unusual to get 6 black cards in a row. So instead, we said our assumption that half of them are red cards must be incorrect, because I got something super unusual. Does that make sense? Yeah. So if you reject H0, it's because if you get something unusual, that's when you reject H0 and say that it can't be right. My null hypothesis must be incorrect. My initial assumption that H0 is true must be incorrect. All right, so here are the steps for identifying H0 and H1. First, write the claim using less than, greater than, equal to, or not equal to. Then, write down H0, which is always, always, always what? Equals, always equals. So, P equals something or mu equals something. You're not supposed to fill these blanks in, by the way. It's just, I'm just saying that P equals something or mu equals something. Right? There should always be equals. So your claim is going to be U equals blank or P equals blank. And then, if your claim includes equals, then H0 is your claim, and H1 will be the opposite of that. But if your claim is not equals, or your claim does not include equals, then H1 becomes your claim, because one of them has to be your claim, either H1 or H0. So if H0 is not your claim, then H1 needs to become your claim. Let me show you an example. We're actually going to give you 3 examples. So the first one, Alberto, read for me.
A medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after the patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute.
Perfect, thank you. Now, if you are the researcher, you want to say that your medicine has no undesirable side effects, right? Take my medication, your heart rate is not going to have, it's not going to change. Which one is going to be, what's your claim? Your claim is that the heartbeat's going to be what? It's going to stay the same. Does that make sense? It's going to be equal to what?
82.
82. The same as everybody else. Does that make sense to folks? Mm-hmm. So my claim is that your heart, if you take my medication, the average heartbeat will still be 82 beats per minute. Is that H0? Is it H0?
Yeah.
Yes, it's the same thing. So my claim is H0. So my claim is H0, which means that H1 has to be the opposite of my claim. What's the opposite of equals? Not equals. So my H1 is going to be, you should all be writing this down by the way, you should be writing down claim in that part. And then H naught is mu equals 82. So then H1 is that mu is not equal to 82. Make sense for folks?
Yeah.
This is a two-tailed hypothesis test because my H1 is not equal to. So it should be all written down in your notes. Does everybody have a copy of the notes? Good? If you don't have a copy of the notes, let me know right now because if you don't tell me right now, I'm probably going to be very upset with you. Okay. Good. Situation B. Lauren, go ahead and read for me.
A chemist invents an additive to increase the life of an automobile battery. The mean lifetime of the automobile battery without the additive is 36 months.
Great. What is his claim?
It will increase.
Yeah, it's going to increase. So what's it going to be? It's going to be what? His mean is going to be, if you take my battery additive, your mean is going to be what?
Not
Greater than 36.
Greater than 36. Does that make sense?
Yeah.
The average is 36. If you take my stuff, you're going to get something larger than 36. Is everyone following?
Yes.
So the claim is that with his additive, the mean is greater than 36. H naught is always what?
Equals.
Equals. So H naught is that it equals 36. Everybody on board?
Yeah.
Is H naught my claim?
No.
No. My claim is greater than. H naught is equals. So I need to make H1 my claim. So everyone following? So then H1 must become mu is greater than 36. Because my claim has to be one of them. Does that make any more sense?
Yeah.
Right tail. Last one. Who hasn't read yet? Alondra, have you read yet? Go ahead.
A contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of the monthly heating bill is $78, her hypothesis about heating costs of the use of insulation are.
So what's your claim?
Less than 78.
Yeah, the mean. Is it a mean or proportion?
It's a mean.
It's a.
It's a mean.
Everyone see that? Everyone see the word average? It's a mean. So claim is going to be that the mean is what?
Less than 78.
Less than 78. It's going to go down. Does that make sense? Because it's going to lower your heating bills. You're not going to pay $78. You're going to pay something less than $78. Does that make sense for folks?
Yeah.
So the claim is that your mu is going to be less with my insulation. Your mu is going to be less than $78. Yeah.
So whatever is less than is going to be left tail and then
Yes.
right.
If it's greater than, it's going to be right tailed. So true.
And then when it's not equal, it's two tail.
All right. So is my claim is that H naught? H naught is always
Equals.
equals. Is my claim H naught?
Nope.
Nope, because my claim is not equals. Everyone on board?
Yeah.
Is everyone really on board?
Yes.
My claim does not involve equals, so my claim is not H naught. So then H1 has to become my claim. H1 is my claim. That's left tail. All right, everybody do problem number 3 on the worksheet. Symbolic form, mu equals something. Or doesn't equal something. Mu something, I don't know. Oh, first of all, is it a mu or is it a p?
Mu.
How do you know it's a mu?
Average.
Average. Great. All right, the average age, that's my mu. Mu is the same as what?
Equal.
Equals, yep. And then we have equals what? 24.6. That is my claim. H now is always
Equal.
equal, so it's going to be that mu is equal to 24.6. Is H not my claim? Is H not my claim?
Yes.
Yes, so then H1 becomes the opposite of that. What's the opposite of equals?
Not equal.
Not equals. So H1 is that mu. Don't forget, don't just put this. Mu is not equal to. Don't forget the mu. Do not forget that, right? Mu is not equal to 24.6. Perfect. So it's one-tailed or two-tailed? Two-tailed, not equal to. Everybody on board?
Yep.
Great. You folks want a little break?
Yes.
All right, so it is almost 9 after, 10 after, we'll say, so we'll say 20 after. Come back to 20 after.
I'm on the 30.
All right, so let's get started.
Oh, it's so good. It is.
All right, so this is to help you folks with step 5.
Alright.
Step 5 on this part and your homework is the part that people will have the hardest time with, and they'll bang their head against the wall the most. So that's why I'm going over this part with you folks now, so that when you get to this in step 5, when you get to these homeworks later on Thursday and Friday and Thursday and Monday of next week, that you will have no issues with them. So the idea is, for the summary, if the goal of your test is to reject, it depends upon what happens if you reject H naught. If H naught is my claim, so my claim is H naught, then rejecting H naught does what to my claim, if my claim is H naught? H naught's my claim, so if I reject H naught, what happens to my claim? It's also rejected. Does that make sense?
Yeah.
If my claim is H naught, then they're together. If I reject H naught, I reject my claim. Is everybody on board? So if H naught is your claim, then in the summary, you're going to reject or not reject your claim. Either I'm going to reject H naught and reject my claim, or I'm going to fail to reject H naught and fail to reject my claim. But if H1 is my claim, so here's H naught, my claim is the other one, H1, then rejecting H naught does what for my claim? It's good, it supports my claim, it's good for my claim. Everybody on board? So if H1 is your claim, then we're doing this whole test to either reject H naught and support my claim, or fail to reject H naught and fail to support my claim. So that's kind of the wording you're going to want. How do you remember to use it? So remember H naught, reject. H1, support. How do you remember? Everyone knows your ABCs, right? A, B, C, D, E, F, G, blah, 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 blah. Q, R, S, C, U, D, over that. Q, R, S. So Q just gets you started. Q, R, S. R, reject. S, support. Everybody on board? So it's just a mnemonic for remembering it. The first one is reject. The second one is support. All right, so let's just look at the following, and just let's see if we can figure out what the goal is of the following. So this one, which one was my claim? He wants to have no undesirable side effects. So his claim was which? H naught. So H naught was my claim. So in parentheses, I'm going to write reject. We're going to either reject my claim or fail to reject my claim. Everyone okay with that part? Next one, my claim was increase, right? So my claim was H1. So am I looking to, as my goal to support my claim or fail to support my claim? Support. Right, so it's not going to be, I'm not trying to reject my claim. I'm going to see if rejecting H naught will support my claim. Everybody, does that make sense, folks? Yeah, support or not support, depending on what happens to H naught. If I reject H naught, that supports my claim. If I fail to reject H naught, then I fail to support my claim. And then the last one is, again, this one was lower, right? So my claim was to lower it, H1. So again, am I going to use the word reject or support here? Support. Rejecting H naught will support my claim. Where H naught is, we're doing the whole test to either reject or fail to reject H naught. And now this step we're just looking at how does that affect my claim. So this part is just all about the claim. since that part of step 5 refers back to the claim, then we have to look about what does rejecting H naught do for your claim. If H1 is your claim, then rejecting H naught supports your claim. It's good for your claim. It doesn't make a whole lot of sense now, but it will next class when we get to step 5. I want to get it in your mind so you start getting used to this concept. Yeah, little by little. Okay. The next thing we're going to talk about is the test statistic. The test statistic, you're going to be filling in some blanks here on your notes. The test statistic is found by converting the sample statistic to a z-score. You're going to find your sample's z-score. I call it test stat, TS for short. I didn't come up with test stat, someone else told me about it. Some student who took it in high school. All right, so we're going to find the test stat. Now let's find the z-score for your sample. How do you find the z-score? Well, first of all, you have this on your handout. Okay, so remember the last one. How often do I know sigma? Never. So you're going to cross that one out, right? The bottom one. Cross that out. Unrealistic. Not going to happen. But for proportion, how do I find the z-score? I take my p hat, the value I want to get the z-score for, subtract p naught, what I expect to get, and divide by standard deviation. What's the standard deviation for proportion samples? Square root of pq over n. For a mean, remember a z-score is how many standard deviations you are away from the mean. So first find out how far away you are from the expected mean. So x bar minus the mean. What is that in standard deviations? Divided by standard deviation. S over square root of n. Good, so these are the two formulas you're going to use for finding your test stat, depending on whether it's a mean or a proportion. Please note that the proportions, remember we're assuming that P naught is true. So the standard deviation we're using there, the square root of PQ over N is the original P, the P naught, the one in the claim. Not my sample, not P hat, it's P naught or P. Same thing. All right, so we will do an example. Molly, you have read, right?
Yeah, no, not today, no.
Great, go ahead.
Okay. Let's again consider the claim that the X-sort method of gender selection increases the likelihood of having a baby girl. Preliminary results from a test of the X-sort method of gender selection involved 100 couples who gave birth to 58 girls and 42 boys. Use the given claim and the preliminary results to calculate the value of the test statistic. Use the format of the test statistic given above so that a normal distribution is used to approximate a binomial distribution.
Perfect, thank you. So first of all, what's my claim? Actually, first of all, what's the proportion of girls that you expect to get? 50-50.
Oh, yeah.
Okay, what's my claim? X-sort claims what? First sentence, read it. X-sort claims what? What's the claim?
Increases the likelihood of having more girls.
Increases. So what's my claim then? It's greater than P is great. Is it a proportion or is it a mean? It's a proportion. How do you know it's a proportion? Do you see the word mean in there? Or standard deviation or average? No, it's a proportion. That's how you know. Okay, so we're claiming that the proportion P is what? Greater than what? Then
Mean? 0.5.
0.5. What do we expect to get?
58.
50%. 50-50. Everybody on board?
Yes.
You expect to get 50% girls. Yes? No?
Yes.
Yes.
So I appreciate you guys trying. At least that's good. So you expect to get 50% girls. What XOR is saying is we can do better than 50%. What is better than 50%? Greater than 50%. Does that make sense?
Yes.
So its claim is that its proportion, the proportion of, if you use the XOR method, your proportion of girls will be larger than 50%. That's the claim. What's H naught? H naught is P is equal to, right? It's always equals. Everyone on board? So then H1 is my claim, P is greater than 0.5. Good? All right, so then I need to figure out what my P hat is. I need to find my test stat. So my test stat, so my P hat is, what's my P hat? What's for my sample, right? So this is a sample. Here's my sample. And what do we get? Yeah, 58 out of 100. That's a sample, 0.58. How do I know which one's P hat and which one's P? The claim. The claim is always your P, P naught, or your mu naught. Everybody on board? Right, so your mu, same thing as mu naught, P, same thing as P naught. That's always going to be whatever is in your claim. My sample is going to be what I got from what I actually ended up from what I got from my results. So my test stat is going to be my P hat minus my P. So P hat minus P over square root of PQ over N. So it's going to be 0.58 minus 0.5 over square root of, remember, we're assuming that P is true. That's 50%. We're assuming the null hypothesis that doesn't change anything. So we're assuming 50% is true, so I'm going to use 50% for P and Q, because we're assuming that that's, the null hypothesis is true. So 50-50 for P and Q over N. So we're going to do 0.5 times 0.5 over N, which was 100. And if we do all that work, we'll magically end up getting, oh, here's the in-between step. We'll magically end up getting 1.6. And remember, before we remembered that before unusual was typically, we know unusual is right around 2 standard deviations. Everyone with me, kind of?
Yes.
So this is definitely not unusual. It's totally, it's well within 2 standard deviations. So not unusual. So maybe it helps you out, but we can't say conclusively. And we're going to talk about this whole maybe it does later on. I mean, that's the problem is that, I feel like that's pretty good, right? But it's not good enough to prove it. And we'll talk about that later. That's what we call a type 2 error, which we're going to talk about in about half an hour. But you're going to talk about it in about 2 slides. Okay, so first, the claim. And here's your claim. So do this problem. Problem 5. Is it a proportion or a mean? How do you know it's a mean? It says mean. And it says standard deviation. There you go. So it means you're going to use the mean and standard deviation formula, right? Don't use proportions.